Hi, good day everyone. Now we are here to present the extrusion metal forming process, which is going to be presented by Hiew Wai Kien, Guan Sheng, Kok Kai Lin, Li Jie, and me, Loo Ji Yu. In this presentation, we are going to discuss about overview of an extrusion process, types of extrusion process, factors that affect the extrusion process, derivation of formula, example of calculation, and defects in the extruded product.
My name is Guan Sheng. The first part in our presentation slide is the overview process of the extrusion, and the contents are what is extrusion, how does extrusion work, and a schematic diagram of extrusion process. Extrusion is the plastic deformation process in which a block of metal billet is forced to flow by compression through the die opening of a smaller cross-sectional area than the original billet as shown in figure 1. And the billet will be compressed into the shape of the die as you can see in this figure, and it is an indirect process. Generally, extrusion is used to produce cylindrical bars or hollow tubes for the starting stock of for drawn rod cold extrusion or forged products. Extrusion process can be hot, cold or hot depending on the type of the alloy, but most of the metals are preheated first to facilitate in the plastic deformation.
My name is Kok Kai Lin. In this part, we will explain about different types of extrusion process. The type of extrusion process will be introduced are the direct extrusion, indirect extrusion, impact extrusion, hydrostatic extrusion, hot extrusion, and cold extrusion. First of all, direct extrusion, also known as forward extrusion, is the type of extrusion that occurs when the direction of flow of metal is the same as the movement of ram. During this process, the billet slides relative to the walls of the container, and this results in increasing frictional force and leads to a higher ram pressure.
I will continue with the indirect extrusion. In indirect extrusion, the ram carries the die and pushes toward the billet, which is cause the metal flow out from the die. Because of the material does not move, this eliminates the relative motion between walls of container. As a result, lower frictional force and lower power is required. But due to low rigidity of the hollow ram, it is difficult to support the extruded workpiece as it exits the die. Here shows the comparison between the direct and indirect extrusion process. Firstly, the material is slid along the chamber wall in direct extrusion. The material does not move during indirect extrusion, but the die moves. Because of this, lower frictional force are generated in indirect extrusion, but high frictional force must be overcome in direct extrusion. Due to less frictional force, lower extruding force is required in indirect extrusion as compared to direct extrusion. Lastly, direct extrusion will result in high material waste, while indirect extrusion will result in low material waste.
Next, I will explain about the impact extrusion. It is one of the cold-forming process used for large-size production. And how does this process actually work? Firstly, a lubricated volume control slag is placed in a die cavity as can see in the diagram. Next, the punch will approach at a very high velocity and strike the metal slag, forcing the metal to flow back around the punch through the opening between the punch and the die. Then the part will be formed. However, the impact extrusion is restricted to softer metals such as lead, tin, aluminium, and copper. The example of this process are toothpaste tubes and battery cases.
For hydrostatic extrusion, the process is limited by the temperature. The billets in the container is surrounded by the fluid medium, and the extrusion is carried out in a completely sealed cylinder that containing the hydrostatic medium. The extruded product has a good surface finish and dimensional accuracy due to the pressurized fluid and effective lubrication.
My name is Hiew Wai Kien. Today I will talk about the type of extrusion. Basically, all the 4 types of extrusion method that mentioned before can be performed either hot or cold. Choice of the type of process is to follow depend on the ductility of the material and the amount of strain to which the material is to be subjected during deformation. Now I will focus on cold extrusion. So what is cold extrusion? Cold extrusion basically is performed at temperature significantly below the melting point of the metal being deformed. Most of the material can be undergo cold extrusion. Example of metal that can undergo cold extrusion is lead, tin, and so on. For example, the part that are cold extrusion is aluminum can, and etc.
The last type of extrusion is hot extrusion. Hot extrusion is done at high temperature. Hot extrusion used to manufacture products from aluminum, copper, and along with their alloys. Hot extrusion usually used to produce bar, tube, wire, strip, solid and hollow section, and brittle materials can be go through hot extrusion in order to change their shape without breaking it. Lubricant is needed in hot extrusion because lubricants help in pushing the material to the dies, so the lubricants must have low shear strength and stable at high temperature.
This part shows the principal variable that will affect the force required to cause extrusion and the quality of material exiting. The principal variables are extrusion ratio, extrusion temperature, speed of deformation, and alloy flow stress. First of all, extrusion ratio is the measurement of magnitude of plastic deformation that is introduced to the billet, whereby it is calculated by the initial cross-sectional area divided by final cross-sectional area. This determines the amount of work done during extrusion. Low extrusion ratio indicates a low amount of plastic strain, and this shows that the amount of work done during extrusion will be less. In fact, material that is extruded with low extrusion ratio will result in a coarse grain structure that is mechanically weak.
For extrusion temperature, it is the most important parameters in extrusion, because as temperature increases, the flow stress decreases. Therefore, the deformation will be easier.
Now, I will talk about the third principal variable. The third principal variable is the speed of deformation. The response of a metal to extrusion process can be influenced by the speed of deformation. Speed of deformation will influenced by the ramp speed. By increasing the ramp speed, can result in the increasing in the extrusion pressure. Increasing in extrusion pressure will speed up the speed of deformation. So that is the effect of the speed of deformation.
The last variable is the allow flow stress. It is actually the stress that required to cause a metal to flow plastically to any given strain. And flow stress is very important because in plastic deformation process, the forming load or stress is a function of part geometry, friction, and the flow stress of the deforming material. Flow stress of the billet material actually depends on both strain rate and temperature. The next part in our presentation slide is the derivation part, which is the formula involved in the extrusion process. For example, extrusion ratio, plastic strain, extrusion strain, ramp pressure, extrusion force.
The calculation of extrusion ratio can be defined by the ratio of the initial cross-sectional area, A0, of the billet to the final cross-sectional area, AF, after the extrusion process, where extrusion ratio Rx is equals to A0 over AF.
For the effective strain or true strain can be derived as ln Rx, where Rx equal to the ratio of A0 to AF, where A0 is the inside area of the container and AF is the area of the extruded rod. For the extrusion strain in the friction condition, it can be calculated by empirical equation proposed by Johnson, which is equal to A plus B ln Rx, where epsilon x is the extrusion strain, A and B is the empirical constant for a given die angle, and Rx is the extrusion ratio.
The next derivation is the ramp pressure. Under the assumption of ideal deformation with no friction and no redundant work, the ramp pressure equals to the average flow stress during deformations multiplied by the ln of the extrusion ratio. And in indirect extrusion, the ramp pressure to perform can be estimated based on the Johnson's extrusion strain formula as follows, which is the ramp pressure equals to the average flow stress during deformations multiplied by the extrusion strain. And the average flow stress can be computed by using the formula K, which is the strain coefficient, multiply the through strain to the power of the strain hardening exponent and divide by the 1 plus n. And in the direct extrusion, the effect of friction between the container walls and the billet will cause the ramp pressure to be greater than the ramp pressure in the indirect extrusion. And this is the formula of the direct extrusion, where the L equals to the billet length remaining to be extruded, and D0 is the original diameter of the billet.
In last derivation, that is ramp force, is taught about F equal to BA. B is the ramp pressure we get from indirect or direct extrusion, while A is the initial cross-sectional area of the billet. So now I would like to show you the example of calculation. A cylindrical billet that is 150 mm long and 40 mm in diameter is reduced by indirect extrusion to a 15 mm diameter, and it provides the die angles equal to 90 degrees. If the Johnson equation have A equal to 0.8 and B equal to 155, and the flow curve for the work method have K equal to 750 megapascal and N equal to 0.15, so we need to determine extrusion ratio, tool strength, extrusion strength, ram pressure, and ram force. So in part A, we use the equation A equal to by d squared over 4. Then we only need to substitute the data provided from the question, and thus we can get the ratio. And in part B, again, we use the answer we get from part A, and we substitute in this equation, and we get the answer in part B. So in part C, extrusion strength that is equal to A plus B ln Rs. Then again, we substitute the data we get from the question, and that's how we get the result again. Then in part C, the question tells us that this is indirect extrusion process, so we need to use this equation. First of all, we need to find the average flow stress during deformation first, which is equal to K times tool strength power of N, then over 1 plus N. After we substitute, then we can find the average flow stress. Then again, we use this result to substitute in this equation, and we substitute the extrusion strength in this equation also, and thus we can get ram pressure equal to 2700 megapascal. And in last part, ram force, we use the ram pressure and multiply by the initial cross-section area of the billet, and thus we can get the result.
In this part, I will talk about the defect in extruded product. There are three types of defect that could occur in extruded product. The first one is center bust, and the second one is piping, and the last one is surface cracking. Now I will talk about the detail of those defects. The first type of the defect is center bust. Center bust defect is the result of tensile stress around the center line of the deformation zone of the workpiece during extrusion. There are a few factors that can cause the crack defect. High die angle, low extrusion ratio, and impurity in the work metal can serve as starting point for crack defect and promote the formation of crack. Greater material movement in this outer region stretch the material around the center of the workpiece, and if the stress are greater enough, the internal cracking will occur. The second defect is the piping. Piping is the defect that occurs when the extrusion is carried on so far that the pipe, which form in the back end of the billet. There are two methods that can reduce the piping defect. The first is controlling friction and minimize the temperature gradient. The purpose of controlling friction and minimize the temperature gradient is to modify the flow pattern to a more homogeneous one. The second method is use a dummy block, which the diameter is slightly less than that of the billet. The third type of the defect is the surface cracking. Surface cracking usually forms when the process of extrusion are too fast. Surface of cracking mostly occur at brittle alloy. Besides that, when the temperature and the speed of extrusion are too high, will lead to high strain rate, and therefore the surface cracking will occur.
Thanks to all my groupmate explanation. From this video, we can understand deeper about extrusion working process. And now there are 4 types of extrusion process, which are direct, indirect, hot, and cold extrusion process. Next, we also introduce the principal variable that can affect force needed for extrusion and also affect the quality of extruded product. Besides, we provide the derivation of the formula involved in the extrusion process, and we also show the example of the calculations. In last part, we have introduced the defect can be found on extruded product. Thank you for your listening and wish you have a good day.